Welcome back, guys. Today news for AI lovers is that Gemini has now memory. Google said that we designed Gemini to be natively multimodal, pre-trained from the start on different modalities. Then we fine-tuned it with additional multimodal data to further refine its effectiveness. This helps Gemini seamlessly understand and reason about all kinds of inputs from the ground up, far better than existing multimodal models, and its capabilities are state-of-the-art in nearly every domain. Our first version of Gemini can understand, explain and generate high-quality code in the world's most popular programming languages, like Python, Java, C++, and Go. Its ability to work across languages and reason about complex information makes it one of the leading foundation models for coding in the world. Gemini Ultra excels in several coding benchmarks, including important industry standard for evaluating performance on coding tasks, and Natural 2 Code, our internal held-out dataset, which uses author-generated sources instead of web-based information. Gemini can also be used as the engine for more advanced coding systems. 2 years ago we presented the first AI code generation system to reach a competitive level of performance in programming competitions. Using a specialized version of Gemini, we created a more advanced code generation system, too, which excels at solving competitive programming problems that go beyond coding to involve complex math and theoretical computer science. When evaluated on the same platform as the original AlphaCode 2 shows massive improvements, solving nearly twice as many problems, and we estimate that it performs better than 85% of competition participants, up from nearly 50% for AlphaCode. When programmers collaborate with AlphaCode 2 by defining certain properties for the code samples to follow, it performs even better. We're excited for programmers to increasingly use highly capable AI models as collaborative tools that can help them reason about the problems, propose code designs and assist with implementation, so they can release apps and design better services, faster. Google's Gemini chatbot can now remember things like info about your life, work, and personal preferences. As by posters on X, a memory feature has begun rolling out to certain Gemini users, including this report likey. Gemini's adds context to the current conversation. For example, tell Gemini to remember foods you like, and the next time you ask the bot for restaurant recommendations, it might tailor its suggestions to your culinary leanings. Memory is only available for subscribers to Google's $20 per month plan, per 9 to 5 Google, and it hasn't yet made its way to the Gemini apps on iOS and Android. Just the web client. And the Gemini UI. Google gives a few examples of potentially useful priming memories, like use simple language and avoid jargon, I can only write code in JavaScript, and, when trip planning, include the cost per day. The company notes that the feature, which only supports English language prompts for now, can be switched off at any time, but that memories are stored until manually deleted. Memory features such as ChatGPT's and Gemini's can be exploited if not carefully engineered with guardrails. Earlier this year, a security researcher found that hackers could surreptitiously plant false memories in ChatGPT to effectively steal a user's data in perpetuity. The statement, Google Gemini has memory, is a simplification that needs clarification. Gemini, like other large language models, LLMs, doesn't have memory in the same way humans do. It doesn't have personal experiences or recollections. However, it does possess several mechanisms that allow it to retain and utilize information. This is the most direct form of memory. Gemini can process a certain amount of text at a time, the context window. Information within this window is readily available to the model for generating its response. However, once the context window is full, older information is typically discarded. The size of the context window is a crucial limitation. Larger context windows allow for more information to be retained during a single interaction. Parameter weights. The model's knowledge is primarily encoded in its vast network of parameters, weights, and biases. The training process adjusts these parameters, allowing the model to statistically associate words, concepts, and relationships learned from the massive datasets it was trained on. This is a form of long-term memory, but it's not directly accessible or easily manipulated. It's more like a statistical representation of knowledge rather than explicit storage. External memory. Gemini remembers info you shared in chats, like your interests and preferences, so you don't have to repeat yourself. Until now, the standard approach to creating multimodal models involved training separate components for different modalities and then stitching them together to roughly mimic some of this functionality. These models can sometimes be good at performing certain tasks, like describing images, but struggle with more conceptual.
Subscribe AI Revolution to stay updated with technology in the modern era. Future will be AI, so be a part of future.